Hello everyone, today we're going to talk about block 6, which is congruence mod N, inequalities and AGM, and the triangle inequality. This is a part a lot of students find really confusing, really hard, and the last two parts were usually covered. Those two parts were usually covered during the first few weeks of 102 lectures, but this term might change a little bit. I guess it's because I think this part is really hard or something. Anyway, the first part, congruence mod, and were usually skipped in 102, but this part is actually really important in later courses. Yeah, and that's why I actually found a lot of questions for you to practice. I really hope you guys can spend time doing those questions. Unfortunately, I will not have enough time to write down all the solutions. What I'm thinking right now is I hope one of you can type your solution out, or write down your solution and send it to me. I can correct it or something, and I can post your solution on the Google Drive so that everyone can see. But we'll talk about that later. Before that, there are some typo on the file I sent to you, so I posted a new link in the information or comment section of YouTube. Please check the new file, okay? Because the old file, when I tried to do the questions, I actually found some mistake there. If you find some typos, please let me know. I will correct it and upload it again. Alright, let's start. First part, congruence mod N. The definition is right here. I hope by now everyone's really familiar with the definition, because, well, apparently you just did your problem set. So I'm not gonna repeat this again. Please have a look. This theorem, we might not use it that much, but I hope you know this. You know that the congruence modulo N is an equivalent relation on Z. And the equivalent relation is actually part of block 5, which is a video I will upload tomorrow. As practice, I think this theorem, the proof of the theorem, will be a really good practice for you for the proof of equivalent relation. So go home and prove this. Okay, prove as homework. The other two, claim and this conclusion, are the two we actually use a lot. So if we have N is a natural number, A, B, R, S are integers. If A is congruent to R mod N and B is congruent to S mod N, then A plus B is congruent to R plus S mod N. So which means you can add them together and you can multiply them together. Okay, this is really important. The proof is really simple, and it requires you just to use the definition above. So the proof is just a definition. Okay, it's just by definition of congruence modulo N. So which means it's simple and it's gonna be a really good practice for you if you to check if you actually understand this, if you actually know the definition. So I would say prove this as homework, and you can always check your answer on the course notes. This conclusion 7.4.4 is really important as well. If A is congruent to R mod n, then A to the K is congruent to R to the K mod n. Okay, we use this a lot as well. And this follow directly from, this follow directly from the claim. But I do want you to know the proof as well, okay? Although it follow directly. I want you to see it, understand it, not memorize any proof. So let's use our knowledge. Let's do the first question. So find the solution of x to each of the following congruences or prove that no solution exists. And when we talk about solution here, we mean integer solution. So we know that 2x is congruent to 7 mod 11. This by definition means 2x minus 7 equals to 11k for some k in integer. Note that when k equals to 1, we have 2x equals to 18 and x equals to 9, which satisfied our condition. Well, x is an integer, okay? Well, some of you might ask, why did I pick k equal to 1? Because k could be any integer. Yes, but for simplicity, I just pick it to be 1 because, well, 1 actually works, right? So sometimes probably 1 will not work, so you try 2 and then you try 3 or a negative 1. Well, you don't want to try a really large number because that's complicated your life, so I don't want that. So in this type of question, we always pick a really small number and try it and see if it works. I'll leave those as your homework. Just do it yourself. It's exactly the same as the first one. Okay, so let's do question 2. Show that there are no integers a, b such that a squared plus b squared is congruent to 3 mod 4. Well, this question, if you remember from your homework, you did something really similar to this question. As always, since you see no here, we can prove a contradiction. So for contradiction, suppose there exists a b in Z such that a squared plus b squared is congruent to 3 mod 4. Alright, now for your homework, we know that a squared and b squared congruent. Okay, how do I write this? It's congruent to 1 or 0 mod 4. Okay, this is from your homework. But during your test or quiz or exam, you cannot use something from your homework directly, so make sure you know how to prove this. Alright, check the solution. A lot of you actually did okay on this question, but I do want you to check the solution posted on Quarkus. Alright. So now we have different cases. Case 1 is a squared is congruent to 1 mod 4. B squared is congruent to 1 mod 4. Then we have a squared plus b squared is congruent to 1 plus 1, which is 2, which is not 3 mod 4. and we have a contradiction. This means contradiction. Because I'm too lazy to write contradiction. Number 2, you have a square is congruent to 1 mod 4. B square is congruent to 0 mod 4. Then a square plus b square is 1 plus 0, which is 1 and not 3. So we have contradiction here as well. The third case, a square is congruent to 0 mod 4. B square is congruent to 1 mod 4. Then we have a square plus b square is 0 plus 1, which is 1, not 3. Contradiction. Last case, a square is 0, is b square, mod 4. Then a square plus b square would be 0, which is again not 3. So we have another contradiction. Therefore, our assumption at the beginning is wrong. There does not exist such A and B in Z, and we're done. Okay? Next question. Let A, B are two odd natural numbers. Suppose that a square plus b square equal to c square and prove that c is not an integer. Here's the thing. We see a square plus b square again, and a, b are natural numbers again. What does this remind me? Is this. Again, from your homework. So you can see how important congruence mod 4 is when you see a square, b square, x square, y square. So in your test or quiz, when you see this type of thing, probably think about them in mod 4. It might be helpful. Okay, so I'll write it down here. Where do I write it down? Here, remark. When we see x squared mod 4 is quite useful. Okay, and this is the first one. The second one, make sure you know how to prove the homework question. Okay, now let's try this again. Proof from homework question. From homework question, we know that, well, since A and B are odd, we know that since they are odd natural numbers, A squared is congruent to B squared is congruent to 1 in mod 4. Okay, this is for your homework. Make sure you know how to prove this. Then we have a squared plus b squared is congruent to, actually I'll write in this way, a squared plus b squared equals to c squared, which is congruent to 1 plus 1, which is 2 in mod 4. Well, in this case, you know that c squared is congruent to 2 mod 4. Again, from homework question, from homework, we know that for all x in in integer, x squared is congruent to 0 or 1 in mod 4, which contradicts c squared is congruent to 2 mod 4. Okay, what does this mean? This means that c is not an integer. Okay, this might seem a little bit confusing. Well, I'll explain this again. So from the homework, we know that since a and b are odd, a squared and b squared, they has to be congruent to 1 in mod 4. So if you add them together, you'll get 2 in mod 4. But from homework, we know that all the integers, for all integers, so let's pick x, an arbitrary element x in z, x squared has to be congruent to 0 or 1, not 2, since we know that c squared is congruent to 2 in mod 4, which means c cannot be an integer. Alright, now let's do the next type of question, which is compute. This is what do we call this? Compute a really large power of a natural number. So the first one, 3 to the power of 2463 is divided by 8. So we need to find the remainder of this. Well, this number looks really scary, right? So it seems like impossible to compute this. So if you would do like 3 to the power of 4, 2463 divided by 8, this seems impossible. But since we know modulo, we can consider 3 to the power of 2463 in mod 8, because, well, the congruence modulo n is like find the remainder class, right? So if we can find this number in mod 8, then we found its remainder. So this question, notice that 3 to the power of 2 is 9, which is congruent to 1 in mod 8. Right? Now we can write 3 to the power of this huge number as 3 to the power of 2, the whole thing to the power of 1231 times 3. Okay? So 2 times 1231 is 2462. Yeah. And then you plus 1 here. So this is that, which will give you 1 to the power of this large number times 3, which is 3 in mod 8. Okay? By this, we know that our remainder is 3. So how do we approach this type of question? The general tip, okay, let me write it somewhere. Let's write it in another color here. So hint for this type of question, you always want to find let's say x to the power of k okay? Such that this whole thing is congruent to 1 or 0 in mod n, okay? Because in this case, we know that 1 to the power of anything is 1, 0 to the power of anything is 0, which will make your life much easier, okay? You'll see how powerful this can get. I'll show you another example. Let's do number 3 together. 243 to the power of 101 is divided by 8. So we need to find the remainder. Well, this number seems really big, 243. So if I consider, well, 243 to the power of 1, and I need to calculate this whole thing in mod 8, it seems a lot of computation. And we know that 102 is not a computation course, which means you might got in the wrong direction. But if we notice this, 243 is divisible by 3. How do I know that? Because 2 plus 4 plus 3 is 9, which is divisible by 3, which means 443 is divisible by 3. So if I divide it by 3, I'll get 81, which is 9 times 9. Well, this gives me some idea. I can write the whole thing as 3 to the power of 5, right? So in this case, I can write this 243 as 3 to the power of 5 to the power of 101. Okay, so this whole question becomes to consider 3 to the power of 505 in mod 8. Well, from 1 we know that 3 to the power of 2 is 1 in mod 8. Okay, let's do the same thing. This will give you 3 to the power of 2. Well, 505 divided by 2 will give us 252 with remainder of 1, so you times 3. This will give you 1 to the power of 252 times 3, which is 3 in mod 8. Alright, this tells us the remainder of this whole thing is 3. Now you see how powerful mod could be. Okay, I'll show you another example right here, because I don't want to only do mod 8. Let's do something else. So again, let's consider this number to the power of something in mod 3 such that the whole thing is congruent to 1 or 0. Well, notice that 7 itself is congruent to 1 in mod 3. And 6 itself is congruent to 0 in mod 3. What does this give us? This gives us 7 to the power of 103 is actually 1 to the power of 103, which is 1 in mod 3. Well, 6 to the power of this huge number is actually 0 to the power of this, which is congruent to 0 in mod 3. Well, that makes our life so much easier. By those two, we know that this whole thing is congruent to 1 plus 0, which is 1 in mod 3. So we know that the remainder is 1. Right? See how powerful it is? I know after all those example questions, some of you still don't know what mod is. It seems like the congruent class is really confusing you. It seems like a magic trick here. But I just want you to know that we are actually using congruence mod and all the time in real life. I'll give you an example. Let's see, we have a clock. Okay, just gonna draw a clock here. So that's 3 o'clock, 9 o'clock, 4, 5, 7, 8, 10, 11. Okay, so this is our clock. Now, I'm telling you, when we tell the time, we have 24 hours. If we use this, we are actually use mod 12. Well, because 13 is 1, 14 is 2, 15 is 3, 16 is 4, and so on. 19, 20, 21, 22, 23, 24, or 0. Well, we know that 0 o'clock, 12 o'clock, they are the same thing. And why is that? Why are those two the same thing? It's because 13 divided by 12 is 1 with remainder 1. Okay? So they have the same remainder class. No, oh, oops, not this. Okay? Same with, let's see, 20 has remainder class of 8. So they are in the same class, right? So, yeah, you can see that we are actually using mod 12 when we tell time. And the same thing goes with mod 4, mod 5, mod 8, mod 20 or anything. This is actually a really powerful, I don't know, powerful technique or something. You'll use it all the time in later math classes. I don't know about CS. I know most of you are in CS, but I really don't know. I'm not a CS person. But it is really powerful, as you can see. As you can see here. Using this, we can compute a really large power, and later you'll learn some theory, like tell you something, Fermat's little theory, what else, Euler's theory, Wilson's theory, those are all in congruence mod, and mod. Actually, those are all for congruence mod P. Not this one, but those two. P, I mean prime. Okay? Using those theorem, it's actually, you can compute a lot of really large number without using calculator. It is like magic. Okay, I actually like this chapter, arithmetic, modular arithmetic. If you are interested, I think you can take the following class, MAT102 You use this a lot. What else? Math 315, number theory. And sometimes we use it in 301, group theory, group and symmetry. This is called group and symmetry. This is number theory. And I think this is discrete math or something. Okay, if you are interested in this, take the following courses. Okay, anyway, let's continue. The next topic is in inequalities and AGM. Again, I don't want to emphasize it too much, but those three topics are really, really, really important. Inequalities, I know a lot of you are taking calculus or analysis. If you are taking 157, 137 analysis, you're using inequalities all the time. Those are really, really important. Inequalities, AGM probably not that much, but triangle inequality, really, really, really important in analysis, and we'll see some examples later. So, start from the beginning. Basic fact. Those you have to know. I don't want to emphasize it too much, but you have to know those. Make sure you know them by heart because you're using them all the time. This proposition is quite important as well. Make sure you know them. Definition, yes, definition. I think this could be like a multiple choice question. So they ask you to compute the arithmetic mean of two numbers and then the geometric mean of two numbers. So make sure you know which one is which. Don't mess them up, okay? Proposition, this is AGM. So I need two real numbers, blah, blah, blah. X, Y is more or equal to this. And the equality holds if and only if x equal to y. And if x and y are non-negative, then you have this. Alright? Make sure you know them by heart. Please know them. And please make sure your AGM is correct. Don't memorize it wrong. I saw a lot of students memorize their AGM wrong and got 0 on the question. I really don't want to see that this year again, okay? I have some remark. Oh my god, I can't spell. Remark. So, you need to be really careful. When you deal with inequalities. Why is that? Well, when you divide or multiple a variable, ask yourself the following questions, alright? Is it positive or negative or 0? Okay? You know that if it's positive, you don't need to change your sign. Do I need to change sign? Okay, if it's negative, you have to change your sign because, well, for inequality, if you times a negative number, you have to switch your sign from greater than or equal to smaller than or equal to, something like that. And really important one, you cannot divide by 0, okay? Please, please, please don't divide by 0, because you cannot divide by 0. It's not defined, okay? Let's do this. Right? Yeah, that is why you cannot divide by 0. Anyway, let's go to the come back to our topic. AGM, yes. Question 5, prove that for any two real numbers xy, 5 over 2a squared plus 2 over 5b squared is greater than or equal to 2ab. And I said you can prove it in two different ways, and I'll show you what do I mean by that. For this question, I have two different ways to prove it. The first one, I call this the elementary way. What I mean by elementary, I mean what you learned from high school before you enter university. So what I mean by this, high school kids can do this, okay? High school kids can even do this, which means you can do it as well. You guys are really smart. I believe in you, okay? I have faith in you. Everyone can do this. So I'm gonna start with this, okay? Although I know we are actually not supposed to start with what you need to prove, but for inequality, sometimes we start with this inequality and work it out till we reach some basic factor, AGM, triangle inequality. So I'm gonna do that, but I'm gonna put if and only if here to make sure my proof is a valid proof, not just rough work. So when I look at this, I see fractions, and I don't like fractions. So I'm gonna get rid of fractions first. So I'm gonna times 10 on both sides, because 10 is a positive number, so I can do that without switching signs. I'll get 5 times 10, I'll get 25 a squared plus 4b squared is greater than or equal to 20ab. Alright, that's our first step. From this, you can see 25a squared is actually 5a, the whole thing squared, plus 2b, the whole thing squared. And I can move this around. I'll get minus 2 times 5 times 2 times ab is greater than or equal to 0. I wrote 20 as 2 times 5 times 2 to show you that this is actually a complete the square question. This is actually not equal. This implies 5a minus 2b, the whole thing squared, is greater than or equal to 0, which is a basic fact, which means we are done. See how simple it is? So formally we should start with the very last step and then go back to what you need to prove. But since every step of mine are reversible, I'm just gonna put double-headed arrow at the front to show that this is a valid proof. You can do that as well to save you some time. The other way is AGM, okay? So I noticed that five over 2 times 2 over 5 is actually 1. So I'm just gonna let x equals to the square root of 5 over 2a y equals to the square root of 2 over 5b, and by AGM, what I mean by AGM is x times y is smaller than or equal to x plus y over 2, the whole thing square. If I sub it in, I'll get square root of 5 over 2a, actually I'm gonna move it around, times square root of 2 over 5 ab is smaller than or equal to, this whole thing square would be x squared plus y squared. So 5 over 2a squared plus 2 over 5b squared plus, okay, so this 2xy, which will give us 2ab over 4. This whole thing will give us, so this cross out, this is 1. 4ab is smaller than or equal to 5 over 2a squared plus 2 over 5b squared plus 2ab. Now you can subtract 2ab on both sides, you'll get 2ab is smaller than or equal to 5 over 2a squared plus 2 over 5b squared. And that is the end of my proof. I do want to talk about something. If you observe, let's go back a bit. If you observe AGM, the equation, the inequality here. So let's take a look at this. This whole thing. Well, notice that we have x times y, and we have x plus y, okay? So when you see inequalities and you see a number, or let's say not a number, you see a triangle times square or a triangle plus square. So triangle and square could be anything, but if you see those things appeared in your inequality, think about AGM. Alright? You think about AGM. In this case, for this question, you see that we have AB, which potentially could be our triangle and square. Okay? Potentially. But you'll see that they don't work that well. So you need to modify it a little bit. Well, how do I know? Some of you will ask, how do I know that my x is this and my y is this? How do I know? Well, because I see an addition here. I see something plus something. So I'm just guessing that probably this is my triangle and this is my square. I'm just taking a wild guess. So I'm just, well, probably this is it. So I'm just gonna try to let this be my triangle or x, this be my square, and work it out. Well, I see it doesn't work, so I take the square root, and well, it works, right? So for AGM, I know a lot of you might struggle right now, but if you do more questions, you would get this intuition, okay? I hope eventually everyone can get this intuition, but you just need more practice. For this question, a be a real number such that a plus 2b is 50. Let's find the maximum value of ab over all such ab. Well, you see maximum value. maximum value, which means we need to find the upper bound of AB, which means you want to find a number m such that AB is less than or equal to m. Alright, well, this should remind you of inequality because, well, maximum value, extreme value should remind you of inequality. A times B, because you need to find AB, right? A times B, this whole thing, well, this should remind you of triangle times square, which is AGM. Okay, so I'm just taking a guess. I'm guessing my method of doing this question would be AGM. So I'm just gonna try. I'll let my x be A, because why not? Y, how do I pick Y? Do I pick Y be B or I pick Y be 2B? That's the question. And I'm gonna say I'm gonna pick Y to be 2B because, well, usually the simple thing would not work. So I'm gonna pick the thing that looks a little bit trickier, which is 2B here. This is like, okay, square plus triangle, okay? And let's see if it works. By AGM, I have xy smaller than or equal to x plus y over 2, the whole thing square. And this will give us 2ab is smaller than or equal to a plus 2b over 2 square. Well, a plus 2b here, which is something we know. We know it's 50. So this whole thing becomes 50 over 2, which is 2ab is smaller than or equal to 25 square, which will give you ab is smaller than or equal to 25 square over 2. You don't have to calculate it out, and I suggest you do not to calculate it out, because when you calculate it, I know a lot of you will make mistakes, and I don't want to deduct mark from you when I see you make this stupid mistake. Okay, so just leave it like that. Some of you might think, oh, we are done because we find our m here. Okay, we have this already. You are not done. The next step is really important. Well, we know that AB is smaller than or equal to 25 square over 2. So right now you want to say that is a maximum value of AB. But we need to verify that this number actually exists. Okay? So notice that if A equals to 25, B equals to 25 over 2, then A plus 2B equals to 50, and A times B equals to 25 square over 2. Then you are done. Okay, now you can say your maximum value of AB is this whole thing. Okay, so this is another remark. When they ask you maximum or minimum value, make sure you find your A and B. Okay, make sure you find your A and B such that the equality holds. Okay, it's really important. They will deduct mark from you if you don't have this. Please, please, please include this step. Okay, really important. Next, question 7. Oh my god, I'm so tired. Okay, let's do it fast, because I need some sleep. Prove that for x, y, u, v is smaller or equal to 2x squared y squared plus 2u squared v squared. And I want to prove it in 2 different ways again. Well, if you take the guess, you know that I'm gonna use complete the square and AGM, right? Why is that again? Well, you see here, we have multiplication. So this could be our potential triangle. This could be our potential square. Okay? Or so you see that we have something. Okay, let me write it as like triangle square. And this whole thing would be, okay, this is 2 times triangle square. This whole thing could be 2 times square. Okay? So, well, we know that complete the square is a plus b square equals to a squared plus b squared plus 2ab. It has a squared, b squared, and 2 times the multiplication, a product of those two. Well, here, if you divide by 2, you have 2xy u v is smaller than or equal to x squared y squared plus u squared v squared, which looks really similar to this, right? So that is my first guess. Let's do it in high school way. I actually prefer this high school way than AGM, because sometimes AGM makes things kind of complicated, so I don't like it that much. But sometimes you have to use it. So, well, first of all, we know that for all a, b in real number, we have a minus b squared is greater than or equal to 0. This is a basic fact. Now we can open it up, will give us a squared plus b squared is greater than or equal to 2ab. Alright, now we can let a be xy, b equals to uv. Then we have, well, a squared is x squared y squared plus u squared v squared is greater than or equal to 2xy uv. Now we times both sides by 2. You'll get exactly what we need for xy uv. And we're done. Same thing for AGM. We let, okay, I'm too tired to write this, so let's just copy paste it. Okay, let a be this, y be, b be that. By AGM, we have ab is smaller than or equal to, actually, this time, yeah, it's the same thing. A plus b over 2, the whole thing squared, so let's do it. Let's do this one, because our AB are greater than or equal to 0. Okay? Oops, I think I made something stupid. Yeah, I should pick this. Okay, yeah, I should pick this. Now we have square root of xy squared uv squared is smaller than or equal to x squared y squared plus u squared v squared over 2. This will give you xy uv. Okay, 2 times xy uv is smaller than or equal to x squared y squared plus u squared v squared. Then you do the whole thing times both sides by 2. You get this. Alright, and we're done. Okay, how many more questions do we have? Okay, we have quite a lot. Let's do it fast. This one. Oh, this one. I like this question. So let's make sure we do this. Again, I can prove it in 2 different ways. I hope you can as well. I'll do one way, because I think some of you might get stuck on this one. So let's do my favorite high school way. Okay, how do we approach this? Alright. Notice that we have this. Since we have to the power of 4 here, I'm considering x squared. So notice that we have x squared minus y squared. The whole thing squared is greater than or equal to 0. That squared minus w squared. The whole thing squared is greater than or equal to 0. If we open it up, we'll get x to the power of 4 plus y to the power of 4 is greater than or equal to 2 times x squared y squared. Okay? Based on this one, we have z to the 4 plus w to the 4 is greater than or equal to 2 times z squared w squared. Now you can add those two inequalities together. You'll get x to the 4 plus y to the 4 plus z to the 4 plus w to the 4 is greater than or equal to 2x squared y squared plus 2 z squared w squared. Now you might say, oh, what do I do now? Do we get stuck here? No, you don't, because look at what we just proved, okay? Look at question 7. Look at question 7. What did we prove? We proved that this whole thing is greater than or equal to 4xyzw. Okay? By question 7. Therefore, we are done, because this whole thing is greater than or equal to this whole thing. That is the end of the proof. Okay? Because I'm so tired, I don't want to do the other way. Your homework is prove it by using AGM, which is exactly the same thing. Okay? I hope every one of you can prove this correctly. But instead of that, I just remind you of something. I marked some of your problem sets, problem set 3. And the inequality question is driving me crazy. Everyone used a different proof. Your proof is really messy. Everyone gave me a really long proof. And it takes me forever to mark that question. So I'll show you my proof, okay? My proof for that question. So the question is, proof for any non, I think it was non, it was for any positive, yeah. For any positive A and B, we have A over A plus 2B plus 2 over B plus 2A is greater than or equal to 1 over 2. Okay? All of you, including the professor's solution, are really, really long, and I really don't like long proofs. My proof is quite short, and I'll show you, and you can use this as well. Okay, this is a really great technique you can use in your your questions or later courses. So I started with 1 over 2, and I claim that this equals to A plus B over 2A plus 2B. Why can I write it as this? Because I know A plus B is strictly greater than 0. Okay? Now I can write this whole thing as A over 2A plus 2B plus B over 2A plus 2B. Alright. Now I'm claiming that this whole thing is smaller or equal to A over A plus 2B plus B over B plus 2A. Why is that? Because we know that 2A plus 2B is greater than A plus 2B. 2A plus 2B is also greater than B plus 2A. So if you divide by a smaller number, you know that the whole thing is gonna be bigger. So what I used is this is greater or equal to this. Okay, this is not clear. This is greater than or equal to this, and this is greater than or equal to that. Therefore, if you add them together, it's gonna be bigger. Okay, and that is the end of my proof. Why? Because I showed this whole thing is greater than or equal to 1 over 2. And that is the end. Alright, see, it's short and saves you a lot of time, and it's really a smart way. I think it's a smart way. And you should use it all the time. You know, divide by a smaller number will give your number bigger. Divide by a bigger number will make your number smaller. So make sure you know that. Anyway, I think I'm done with AGM. Let's move to the next topic, the triangle inequality. Okay, I don't want to emphasize it too much, but I have to say triangle inequality is really important. Really, really, really important. Probably not in this course, but in analysis, in function, we use it all the time. All the time. Please make sure you know this. Okay? Definition here, I'm not gonna emphasize it. Read it yourself. You should know this by heart. Proposition, yes, you need to know this as well. Not especially, all of them are important. Make sure you know all of them by heart. Okay, and this is the triangle inequality. I'm pretty sure you guys proved this, so I guess we can use it. I'm not sure. Actually, I'm not so sure. But when I took this course, we proved this in class. so I'm guessing you can use it directly, but I'm not so sure. Please confirm with your coordinator or check your textbook. If they proved it in textbook, you can use it directly. Anyway, let's prove the inverse triangle equality, which is this. Okay. Why did I write proof in two ways? I'm making my life so much harder. I should never do this. But okay, let's prove it in two different ways. Okay, now I know, because I do want you to show you both ways so that you have some idea of how to do this type of question. My first proof does not even involve triangle inequality. It's based on some basic facts. Okay, so let's do this. I'm gonna start with this. The absolute value of A minus the absolute value of B, the whole thing square, is equal to this. Okay, do you agree with me? Yes, I think you agree. Okay, let's move on. This will give us A squared plus B squared minus 2AB. Okay, I hope you agree with me. This is based on basic fact here, alright, and here. I'm only using those, okay? Now, this claim that this is smaller than or equal to A squared plus B squared plus 2AB. I think it's quite clear because, well, both term has A squared plus B squared, and this term, it's subtract a positive number. This one add a positive number. So of course this one is gonna be greater. I think it's quite clear, but if you have questions, feel free to ask me in comments or email me. I think everyone knows my emails, so yeah. Now this whole thing is just A plus B squared. Okay? Now if you square root both sides, what I mean by both sides is this side and this side, you'll get the absolute value of this minus this is smaller than or equal to the absolute value of A plus B, which is what we need to prove, and we're done. Okay? The second way involves triangle inequality. Yeah, now I remember. That's why I want to show you both way, because both way are quite important. This one we consider different cases because we have two absolute value symbol here, so we want to get rid of one, which is why we consider cases. So the first case is when the absolute value of A is greater than or equal to the absolute value of B. Then this whole thing becomes A minus absolute of A minus absolute value of B is smaller than or equal to A plus B. So this is what we want to show. Alright, I'm gonna start with A. No, not A, this absolute value of A. I can write it as A plus B minus B. Okay? This technique is so useful, so important. You add 0. So you add a number and subtract this number. Okay? So important. Make sure you understand this. By triangle inequality, this will give us A plus B, the absolute value of A plus B, plus the absolute value of B. Some of you might ask me why it's plus here. Because this is plus minus b. Okay, and this is your first term, this is my second term, and that is why this is plus here. Alright? Anyway, I'm gonna erase this. Now, if you move this term to the other side, you'll get absolute value of a minus the absolute value of b is more than or equal to a plus b, which is exactly what we need to show. The other case, this is smaller, then we want to show absolute value of b minus the absolute value of a is smaller than or equal to the absolute value of a plus b. Well, this is this is like the same thing, but I start with b. Again, I can write it as b plus a minus a. And then, oops, okay, I'm gonna write this by triangle inequality. Okay, this apply triangle inequality, we have a plus b plus the absolute value of a, again by triangle inequality, and if you move it around, you'll get the absolute value of b minus the absolute value of a is smaller than or equal to a plus b. And we are done. Proof. Well, you see absolute value symbol, apparently you need to use triangle inequality. So we have this. And you know that we need to prove this is smaller than or equal to this. Notice that they have b here. We don't even have b here, so I'm gonna introduce b by adding and subtracting b. Okay, so I'm gonna subtract b and plus b minus c. By triangle equality, this is smaller than or equal to a minus b plus the absolute value of b minus c. And that is it. Okay? Again, make sure you know this type of technique. Add a number and subtract the same number. Okay, this is really important, especially for the students who are taking 137. I know you just had a test. You need some rest. I need some rest as well. Yeah, especially for people who are taking 137, you know this technique is really important, especially when you need to show, let's say, epsilon, delta, definition of limit. You know, when you try to prove a limit exists, this technique, you use it all the time. I don't know if you used it before, but it's really common technique, really useful, really nice. Okay, so anyway, if you need more practice, because I'm too lazy to type the questions up, and I can't really find more questions based on this, so please do the textbook questions. Those are really nice questions. I love your textbook. I think it's one of the best textbook that I've ever used. So make sure you make good use of it. And that's the end of my video. Thank you. Thank you everyone who's been with me. It's so late and I'm so tired. Thank you for watching my videos. Anyway, I'll see you tomorrow. Not really tomorrow, but I'll post another video tomorrow. Anyway, good night.